Let's see if we can use conservation of energy to calculate an unknown height. Let's say we have a 100 kilogram block. It's initially at rest on top of this perch here, and then it gets pushed down this incline. We're looking at the same block at two different times. Initially it's at rest, but the final time it's moving with a velocity. We're trying to calculate the final height that this block is at. So what you need to do is recognize something. There's going to be an initial mechanical energy and a final mechanical energy, which represents the block at two different times. But conservation of energy tells us that the initial mechanical energy is going to equal the final mechanical energy because energy has to stay conserved. Now, what I can do is take these equations and I can replace them with the initial kinetic and potential energy and the final kinetic and potential energy. Notice this is the total initial mechanical energy and this is the total final mechanical energy. Now, kinetic energy depends on velocity. Potential energy depends on height. Notice that initially we don't have any kinetic energy because we don't have any velocity. The velocity is zero. We're at rest, so we can get rid of the initial kinetic energy. Now, for this final point, we have both a velocity and a height, so we have to keep potential and kinetic energy. So we're going to end up with this equation. Now what I'm going to do is I'm going to replace the potential and kinetic energy with the corresponding equations. Gravitational potential energy is mass times gravitational acceleration times height. Notice we have the initial height, which represents this height, and the final height, which represents this height. This represents the block at our final position. This represents the block at our initial position. Now notice here that I have mass in every single one of these equations, so what I can do is I can cancel the mass across the board. Now I can plug in my variables. Gravitational acceleration on Earth is 9.8 meters per second squared. The initial height is 50 meters, which I can plug in. The final velocity is 30 meters per second. Now the only thing that I don't have is my final height, but that's the height we're trying to calculate. So what I'm going to do is I'm going to start by simplifying both the far left and far right side of this equation. If you evaluate both of these, you should get 490 on the left side and 450 on the right side. I can subtract both sides by 450. 490 minus 450 is 40. Now what I can do is divide both sides of the equation by 9.8. That gets the 9.8s to cancel, and 40 divided by 9.8 is approximately 4.1 meters. So our final height is approximately 4.1 meters.